Hello, and I'm John Rutger. I had problem 14 from section 4.3. The problem states use partial fractions to find the inverse Laplace transform of the functions in problems 11 through 22. We have 14. The problem is given as shown up here. Okay, so we'll get started. Right away, the bottom, we can factor out an s. So this is actually equivalent to 5s minus 4 over s multiplied by s squared minus s minus 2. And then this is actually, we can factor this out some more, and in the end we're going to have 5s minus 4 over, well, s minus 2 s minus 2 multiplied by s plus 1 looks like that works. So we'll have s times s minus 2 and s plus 1. From there then we can right away go into partial fractions to try to solve this. So we're going to have a, b, and c. So our a, this is going to be equal to our a over our s plus our b over s minus 2 plus our c over s plus 1, and that'll be it. Okay, so now we're going to multiply. So we all know, so you take our a and multiply it by our denominators. That's how I've just learned it. So we're going to have a times s minus 2 times s plus 1 plus b, and that's going to be, put this in parentheses so it's the same, s plus 1 plus c times s again, and s minus 2. Okay, so this is all going to be equal to, I ran out of room, but this is all going to be equal to 5s minus 4. So we can start actually, we can just put s's in since there's cancellations within the equation. So I'm going to start off, I'm going to put in s equals 2. So for s equals 2, we're going to get rid of our a here. We're going to keep our b, and that's going to be 2 times 2 plus 1, 3, so 6b. And that's going to be equal to something. Oh, shoot. I should go through the whole problem first. Okay, so then we'll see that it cancels down here too. So it will be equal to, so you put 2 in for 5s. That's going to be 10 minus 4, that's 6. So we're going to have 6b equals 6, but that's just b equals 1. And now we are going to put in s equals negative 1. So we'll also see that cancels here, and we're going to be left with c times negative 1 times a negative 3. So this is going to be 3c, and that's going to be equal to, let's see, a negative 1 in here, that'll be negative 9. And then dividing that out, c is going to equal a negative 3. From here then, we can see in our equations that we'll always have an s squared, and there's going to be an a, b, and a c in front of it. So we can use the equation a plus b plus c equals, well, there's no s squared up here, so that's going to be 0. From there, we can put in our b and c that we found, which is going to be a plus 1 minus 3 equals 0. It turns out our a is going to have to be equal to 2. So we're putting that back into the equation right here, our partial fractions. We're going to have 2 over s plus our b, which is going to be 1 over s minus 2 plus, well, that's going to be minus, I'll just keep, plus a negative 3 over s plus 1. Okay, now we need to do the Laplace inverse. So we can see that this is just 2 times 1 over s. 1 over s is 1. So this is going to be 2. And over here we have, it looks like what would be an e, and this is our a. And since that's already negative, it'll be our plus e to the 2t, if I'm not mistaken. And then this is just a negative 3 times 1 over s plus 1. That is our a, but it is negative. This needs to be a negative 1 because this is really equal to s minus negative 1. So we're going to have a negative 3 times e to the negative t. And that's our equation. Thanks for watching.